Chimera can be used to display the hydrophobicity of a molecule's surface. The default is a red, white, blue color scale, where red is hydrophobic or water repellent, and blue is hydrophilic or water attractant. Visualizing the hydrophobicity may help the viewer better understand the function, localization, or behavior of a particular molecule. For example, different regions of a transmembrane protein may have different degrees of hydrophobicity depending on which regions of the protein sit inside or outside the membrane. The inner portion, or the tail regions of a lipid bilayer, are hydrophobic, so any region of a protein that sits within a membrane tends to be hydrophobic as well. The outer lipid heads of the phospholipid membrane are hydrophilic and surrounded by water molecules, so any region of a transmembrane protein that sits outside of the membrane tends to be hydrophilic as well. We can predict which portions of a transmembrane protein sit inside and outside of the phospholipid membrane by looking at its hydrophobicity. In Chimera, open the PDB file 1fx8 by clicking File, Fetch by ID. Type 1fx8 in the box and click Fetch. 1fx8 contains a copy of an aquaporin molecule. Aquaporins are transmembrane transport proteins that form a pore in the membrane. This pore allows for the transfer of water molecules through the cell membrane. You can see the water molecules sitting inside the pore. Hydrophobicity happens to be programmed into Chimera as one of the presets. To quickly display the surface of the molecule and color it based on hydrophobicity, click Presets, Interactive 3, Hydrophobicity Surface. As you can see, the central region of the aquaporin is mostly red or hydrophobic. This is the region that would sit inside the hydrophobic membrane. The top and bottom of the surface have more blue or hydrophilic regions. These are the regions that would sit outside the membrane where water is. We already knew how this aquaporin sits in the membrane, but visualizing hydrophobicity of less well-characterized proteins can hint at how they interact with their surrounding environments.